We're also going to use LCDs to solve rational equations, and rational equation now starts to put equals in there. And LCDs are good to help us here as well. Let's think about what the LCD is here. Rational equation, by the way, would be a rational expression equal to a rational expression, or a fraction equal to a fraction in a sense. And what we can do here is, again, calculate the LCD. What do we see along the bottom? Well, I see an x plus 4. Put it in parentheses because it's not the only factor. And we see a 42, which is a number, but it stands alone as a factor. LCD would be 42 times x plus 4. And according to these notes, I will multiply both sides by the LCD. So I'm going to multiply this by the LCD. 42 times x plus 4. Notice I'm putting it on top here because when you multiply a fraction by a number, then it's like saying that over 1. So this does go to the top. If I multiply the left-hand side by this, I have to multiply the right-hand side by this as well. All right. And what we have here, again, is the LCD on both sides. And what's so great about this is the LCD contains every factor you see on the bottom. So what's now going to happen? Well, your bottoms are going to cancel out. That's why we multiply by the LCD. Now, I have to clean some things up here. This is x plus 9 times 42. And anytime I have a binomial that's not the only factor, we do want to close that in parentheses. So let's go ahead and distribute. This is going to be 42x. And then 42 times 9, I believe, is 378 here. And over here we have 3 into that factor, 3x plus 12. So notice how much easier it now is that the bottoms are going away. So we've been able to do this one for years. We're just going to solve for x. So this is 39x. And then we'll subtract our 378. So we get 39x is equal to negative 366. Divide both sides by 39. And we get here, not a very lovely answer, but I'm not sure that it'll reduce, but we end up with negative 366 over 39, which of course you can, I got a little bit too low there, but it's just negative 366. If you can see it down here, let me raise it up. Over 39. You can still put that in your calculator and check that. Okay, here we have 8 over x plus 6 equals 8. Again, we want to multiply both sides by the LCD. Well, what's our LCD here? This LCD is very easy to come up with because there's only one denominator. When there's only one denominator, LCD will be that denominator. So LCD is x. So I'm going to multiply everything I see by x, which is perfectly legal as long as you do it to both sides to compensate, both sides of the equation. So that will get rid of the denominator, leaving x, or 8 rather, after the x is canceled, plus 6x equals 8x. And again, once you get rid of the denominator, life's much easier here. I'm just going to subtract 6x from both sides. So 8 is equal to 2x. And we get x equals 4. And anytime you have an equation, when you get to a solution, I recommend you go back, plug it in to see if that solution checks out. And this one we have 16 over x minus 3 minus 22 over 2x equals 1. And what I recommend you do here, you may notice the 22 and the 2 will reduce. So we can save ourselves a little aggravation later in the problem if we just go ahead and reduce that to 11 over x. And had you left it, you would have been okay as well. But our LCD this time, it's got to have the x and it's got to have the x minus 3. And I do need to write both of those. Remember, x is its own factor, x minus 3 is its own factor because these are attached by the minus sign. So I have to list both of those. So I'll take everything in here and multiply by the LCD. again, that's going to get rid of all of our denominators. 16x minus 11 times x minus 3 and then over here we do have x squared minus 3x. And this does cause it to be quadratic. Let's clean this part up. So 16x minus 11x plus 33 equals x squared minus 3x. Okay, so we'll get everything over to one side. Subtract the 33 also. Yeah, my room is limited here, so I had to readjust and put this back up to the top. But after you clean that up, this is a quadratic equation. When you have a quadratic equation, which means x squared, by the way, we generally want to get everything to one side and put a 0 here. And that allows us to factor. X minus 11, x plus 3. All right? And we're solving. In this situation, we know to solve means to find the value of the variable that makes the equation true. Well, we want to allow either one of these to be 0, because if either one of these equals 0, then the whole equation is made true. So I set both of them equal to 0. So I get x equals 11 and x equals negative 3. And what you do want to do here is go back and look at the original equation and make sure that neither one of these are excluded values. Here you're okay. Both the 11 and the negative 3 are legal solutions, so to speak, because if you plug both of them back in, it does not put a 0 on the bottom. But if either one of them did cause a 0 to be on the bottom of the original equation, you would just cross that out, toss that out. Here that doesn't happen. Another thing I'll mention about rational equations is if you have just one fraction equal to one fraction, as we did in our first example, then it is okay just to cross multiply. You don't necessarily have to multiply by the LCD, but the LCD is going to work every time. So I just want to present that to you, that if you have a rational equation, multiply by the LCD, that eliminates your denominators and allows you to factor from that point.